Have you ever wondered what's hotter than the hottest stars in the universe? A journey through the cosmos reveals a fascinating array of celestial bodies, each with its own unique surface temperature. Let's start with the typical stars with their plasma-rich photospheres radiating at a cozy 2700 degrees Kelvin. But as we move up the scale, things start to heat up. The most massive main sequence stars? They burn at a blazing 50,000 degrees Kelvin. And these are just the opening acts. Take a look at white dwarfs, the remnants of red giants. These stellar ghosts glow at a scorching 150,000 degrees Kelvin. Then, there are the highly evolved Wolf-Rayet stars, rare cosmic beasts that can reach a surface temperature of 210,000 degrees Kelvin. But believe it or not, there are things in the universe that are even hotter than these stars. So, what's hotter than the hottest stars? Let's dive deeper into the cosmos. We've marveled at the scorching temperatures of the most massive main sequence stars, sitting pretty at around 50,000 Kelvin. But my friends, we're just getting started. Beyond these celestial giants, we find neutron stars like the Crab pulsar. These astronomical anomalies are not just hot, they're blistering, radiating at a temperature of approximately 600,000 Kelvin. That's over 10 times hotter than the most massive main sequence stars we just talked about. But hold on to your space helmets because we're going to crank up the heat even further. Have you ever heard of X-ray emitting gas clouds? These cosmic clouds are not your typical fluffy white formations you see on a sunny day on Earth. These are superheated X-ray spewing monsters that can reach temperatures exceeding 100 million Kelvin. Yes, you heard it right, 100 million. Now, let's take a journey to the heart of the stars, to the stellar cores. These are the engines of the stars, the places where nuclear fusion happens, converting hydrogen into helium and releasing an enormous amount of energy. These stellar cores can surpass a temperature of 300 million Kelvin. That's 3 times hotter than our X-ray emitting gas clouds. But wait, there's more. We haven't even reached the neutron star interiors yet. These are the remnants of supernovae, the spectacular explosions marking the death of massive stars. These interiors can reach an unfathomable temperature of around a non-illion Kelvin. That's a 1 followed by 30 zeros, creating what's known as quark-gluon plasmas. However, the universe has more to offer when it comes to extreme temperatures. And we're about to discover just how hot things can really get. Hold on tight as we're about to venture into the realm of the most extreme temperatures in the universe. In this journey, our first stop is the supermassive black holes. Now you might think, aren't black holes supposed to be cold and dark? Well, that's only half the story. While the black hole itself is indeed a region of space from which nothing, not even light, can escape, the environment around it is a different story. Around every supermassive black hole, there's an accretion disk, a swirling vortex of gas and dust, heated to incredible temperatures by the immense gravitational pull of the black hole. As the matter in this disk spirals inward, it accelerates and heats up, radiating a tremendous amount of energy. This energy can heat the surrounding particles to temperatures of up to 10 septillion degrees Kelvin. That's a 1 followed by 24 zeros. But wait, there's something even hotter. Let's rewind the cosmic clock to the very beginning of our universe, to an event known as the Big Bang. This event, which occurred around 13.8 billion years ago, was not just an explosion, but the very moment of creation itself. In the fractions of a second after the Big Bang, the universe was an incredibly hot, dense point where all matter and energy in existence was contained. During this time, the universe was so hot and dense that even the basic components of atoms, protons, neutrons, and electrons, could not yet form. Instead, the universe was filled with a quark-gluon plasma, a state of matter that only exists at extreme temperatures. The Big Bang remains the only known event in history to have created conditions hotter than a supermassive black hole. So, next time when you look up at the night sky, remember that our universe is a fascinating place where temperatures can reach unimaginable extremes, far beyond the heat of the hottest stars.